Okay, so what we have now is we have the loop invariant, we have the precondition and the postcondition. The loop invariant together with the postcondition dictated what the loop guard should be, and then the precondition together with the loop invariant has told us what the initialization step should be. But remember that we have to make progress through the vectors or else the loop may not terminate. And what's going on inherently? Well, notice that here in the initialization we said the top part of x and y must be of size 0. And notice that the loop guard tells us that when we're done, the size of the top part of x and therefore the top part of y must be equal to x. That tells us that we are going to move through these vectors from first element to last element. And how do we express that? Well, the way we express that is by saying, look, the top part of x and the bottom part of x, we are going to repartition, and what we're going to do is we're going to expose the top element of the bottom part so that we can take it from the bottom part to the top part at the bottom of the loop here. Okay, so the way we choose to do that in our notation is to say, let's relabel the top part of x as x0. Let's give a label for the first element of the bottom part. Let's call it chi1, and here we're using a lowercase Greek letter because that inherently then tells us that that's a scalar. And then there is the rest of vector x. And then similarly we take the top part of y and the bottom part of y and we partition it into the top part. We're going to use the Greek letter psi for the top elements of the bottom part, psi1, and then the rest of that. So what this says is, relabel x top x0, take the bottom part, split off the first element, call it chi1, and call the rest the subvector x2, and then something similar for y. We could then say where chi1 and psi1 are scalars, but that's kind of implicit in our notation because we chose to use lowercase Greek letters there. Okay, and then at the bottom of the loop, in step 5b, you say, okay, now the top part and bottom part of x are going to be redefined. The top part of x is going to become x0 chi1 because that element is now moved across from the bottom part to the top part, and therefore the bottom part is now what we relabeled to x2, and then the same thing for y. Okay, and what do we have now? We have a way of expressing that we are moving through the vectors from the first element to the last element, and we have a way of identifying that element that is being moved from the bottom to the top. And notice that that's very much like the splitting off of the last, or actually in this case of the first element of the quantifier when we express the quote-unquote bottom part with a quantifier.